In this lesson, I'll show you 5 examples on how to find the derivatives of implicit relations. Normally when we find the derivative of an expression, let's say we have d over dx for the expression 3x squared, we find the derivative using the rules we've learned, and the derivative of 3x squared will be 6x. But what we don't normally write after is the expression dx over dx, because dx over dx becomes 1. And that's always the case when you are deriving something with respect to the same variable we take the derivative of. Now that's not the case with question 1. In question 1 they want us to find the derivative with respect to x for the function 2y plus z to the power of 3. Y and z are not the same as what we're taking the derivative with respect to. And this is where implicit differentiation comes into play. So let's start with question 1. We'll start by taking the derivative of 2y, and we can use the power rule. So the derivative of this is 2, and we'll write down dy over dx. And to take the derivative of z to the power of 3, we use the power rule. That becomes 3z to the power of 2 dz over dx. We've just implicitly differentiated the expression. Let's move on to question 2. Here we need to use the product rule, so we take the derivative of this, multiply it to z, and then add the derivative of z times w. The derivative of w is 1, and beside it we'll write down dw with respect to t, so dt, and the z stays the way it is, plus, now we take the derivative of z with respect to t. The derivative of z is 1 dz over dt times w, leaving us with z dw over dt plus w dz over dt. I've sandwiched the expressions that we just found so that I have more room. Moving on to question 3. Once again, we need to use the product rule here. We'll start with the derivative of x to the power of 2. That is 2x, and since it's with respect to t, we have to write dx over dt, leave y to the power of 3 the way it is, plus, now we find the derivative of y to the power of 3 with respect to t, dy over dt, and leave x to the power of 2 the way it is. And of course you can combine these terms together, where you end up with 2x y to the power of 3. By convention it looks nicer this way, plus 3y to the power of 2 x to the power of 2 dy over dt. Let's move on to question 4. This time they want us to find the derivative of x with respect to y. So normally we see it with respect to x. They're trying to confuse us here. Start from the left side. This becomes dx over dy. This becomes 2y, and we don't need to write down anything afterwards because it's with respect to y. In other words, it would be dy over dy, and there's no need for that. Here's another term that's written in terms of y, so we end up with negative 3 for that. And plus 0, well, we don't need to do anything with that. That becomes 0. This is our final answer. Moving on to our last question in this lesson. We have to implicitly differentiate the expression x to the power of 2 plus y to the power of 2 is equal to y to the power of 3 minus x. And it's in terms of x. This one becomes 2x with nothing beside it. This becomes 2y dy over dx. This becomes 3y squared dy over dx. And this simply becomes negative 1. What we can do next is group like terms together. Take a look. We can group this and group this together and bring that over to the other side, where we get 2y dy over dx. That's this part. Bringing that over makes it negative. And over here on the right side we have negative 1 minus 2x. We can factor out the dy over dx, leaving us with 2y minus 3y squared is equal to negative 1 minus 2x. And now we can divide both sides by 2y minus 3y squared. leaving us with the expression on the right side as our answer. And of course, you can factor out a negative here if you would like, but that's not necessary. So there you have it. 5 examples on how to use implicit differentiation.